Assalamualaikum, selamat sejahtera and a very good day for the evaluators. My name is Muhammad Firdaus bin Muhammad Salan. Today, I am presenting my final year project, which is PAPSOTO25, that also stands for Predictive Analytics for Post-Stroke Occupational Therapy Outcome 2025. It was an intelligent clinical decision support system focused on predictive analytics for post-stroke occupational therapy outcomes, and this work has been developed under the invaluable supervision of Dr. Fadatul Hafidah Hassan. To provide a quick overview, PAPSOTO25 is an intelligent clinical decision support system developed for CST405 intelligent computing project at University of Malaysia. It utilizes long short-term memory or LSTM network to predict high motor recovery for stroke survivor undergoing constraint-induced movement therapy or CIMT by safely analyzing the identified patient demographic and therapy intensity metric. The core engine estimates progress trajectory through the motor activity log or MAR scale to achieve absolute medical trust and regional PDPA 2010 compliance. The platform integrates Sharp for explainable AI insight, wrapped inside a stateless, high-performance, fast API architecture, ultimately aligning with UN Sustainable Development Goal 3 to enhance the independence and quality of life for stroke survivors. Our project addresses three severe vulnerabilities found in contemporary rehabilitation workflow. First, clinical uncertainty, where therapists currently lack dependable data-driven tools to accurately forecast individual recovery trajectories. Second, overgeneralized analytics. Modern machine learning alternatives are too broad, focusing on global upper extremities instead of specialized post-IoT hand and fine motor recovery. And third, the black box barrier. Existing deep learning model lack clinical interpretability, making it impossible for clinicians to audit the rationale behind a prediction, which block clinical trust. To resolve these challenges, the project fulfills three primary system objectives. Objective 1 is to accurately estimate post-IMT health recovery outcomes using longitudinal motor activity log variable. Objective 2 is to design and implement an explainable machine learning framework that predict dysfunctional recovery while providing interpretable narrative insight for real-time clinical decision making. Finally, Objective 3 is to build an active decoupled clinical decision support dashboard to optimize rehabilitation workflow and protect data integrity. The proposed solution is an intelligent decision support system (CSS) designed to transition stroke rehab from traditional static tracking into proactive data-driven forecasting. This is achieved through three key pillars. First, a deep learning sequential architecture utilizing an LSTM network to process complex information such as total dosage, stroke chronicity, pathology type, initial severity, and engineered polynomial interaction term to accurately project our target variable, the absolute change in the motor activity log or data MAL. Second, explainable AI integration. We integrate the game's theoretic sharp algorithm into a post-hoc reasoning layer to break down abstract neural network weight into exact local feature attribution. This then renders transparent visual representation of patient strength, facilitators, and restriction drivers to establish clinical trust. Third, an insightful clinical dashboard, a touch responsive interface engineered to seamlessly visualize and display this critical high-density clinical insight directly at the patient bedside to optimize daily rehabilitation workflow. PAPSOTO25 is deployed utilizing a three-tier software architecture pattern to isolate computing duties. The presentation tiers leverage the Next.js F16 and React 19 to render a responsive, fluid clinical user interface natively on desktop workstation or mobile tablet. The application logic tiers run a stateless Python fast API server that handle data preparation, pipeline, and deliver deep learning model inference in under 500 milliseconds. Lastly, the data tier utilize a cloud support-based PostgreSQL cluster with rigorous row-level security to enforce complete data compliance with PDPA 2010 rules. Empirical testing mathematically validate our framework clinical value. Our optimized STM model achieve high robust performance metric, locking down an R-square score of 0.5828 and incredible type mean absolute error or MAE of 0.6749 ml point. This technical foundation delivers game-changing clinical impact through post-hoc sharp calculation that transparently map local strength facilitators and restriction driver on the dashboard. Furthermore, our hardware-free soft sensor flag patient regression and fatigue without requiring expensive biometric hardware, safely accelerating functional independence in line with SDG3 benchmark. Addressing our PLO8 project core, PAPSOTO25 possess outstanding commercialization readiness and potential. The platform operates on highly scalable, subscription-ready software as a service model tailored for rehabilitation infrastructure and hospital. From a development standpoint, our core intelligence engine and decoupled front-end dashboard are 100% functional and ready to pre-commercialization pilot deployment. Economically, the software replaced expensive physical telemetry system with predictive software soft sensor, drastically reducing capital barriers to entry for smaller, resource-constrained suburban medical facilities. Okay, right now I will be presenting the system demo of the PAPSOTO25 final year project. So this is the login page whenever you come to the website. There's multiple level of login here. For now, I will be presenting the doctor punya level of login lah. So you can enter here your email here uh, for your account. You can sign into the dashboard. Anyway, if you sign into the dashboard, we come to the main dashboard here, which is will show you everything lah. You get data set here. If you push this button, we'll give a CSV file that can be used to extract all the data that are available in the database for this particular page. In this dashboard also we have the number of activation, average clinical gain, and also total therapy for the whole clinic. So here we have a clinical action inbox, which in easier term is basically a warning whenever anything happens. Like here you can see that Bob has a red outline here showing that he is very critical. For the warning was severe pain level, while the yellow one show the medium level of like uh, alarm, which is the recovery plateau. And under here, you can also like see all the patient that was in the clinic or in the database. As you can see here, have their own color and their own meaning to the color lah. Like the red one has a clinical alerts, which is like here Bob. The yellow one will be warning, which is it's not severe, but also not considered stable. And the white one is stable, which is on track for the recovery. Here also you can filter it by search bar. You can also like uh, filter it by stroke type, maybe ischemic or hemorrhagic. You can also filter it by which part of the hand that are affected by the stroke. And here, supposedly you can see what is the upcoming schedule. We will also come up with here lah, upcoming schedule. So in here, how you can do. Usually the doctor will add a patient here. Here you have a patient punya form. So maybe you can put here uh, Muhammad Firdaus, my name lah, Muhammad Firdaus. Maybe I'm 23, I'm a male. I submit left-handed. Maybe I have already faced this for like 5 months. My lesion site is the left hemispheric, which is the left different part of the brain. And here you can put any additional detail into the form lah. So for now, just link it blank. Then you can assign nurse to it. Right now we have only one nurse, which is Nur Siti Aminah lah. So just assign it to Siti Aminah here. In the future, when there is multiple account, we can assign to different nurses and also assign to multiple nurses also. So just add to the HR system, check successfully. We come here. You can see right now the dashboard is quite blank since there's no data was added to the patient yet. So here also we don't need to add. Okay, so you need to go to the baseline, which is the initial state of the patient. Basically, the first time they are doing the therapy, maybe the first time they are doing for 30 minutes, since it's the first time. You can choose any date to start the therapy. We choose it today for now. Then choose the intensity of the therapy itself. The intensity is like 2 cc in the starting, but the client said that it was very hurt for him, level 4 or 5. And you can here also you can choose what focus they do on the therapy itself, maybe reach, maybe carry, maybe manual, maybe any simulation. So here we just choose all of it lah, just to test the first time of the patient, the first condition of the patient itself. Then we go to the next step. Here there's some uh, activities that was used to measure the motor activity log of the patient itself. So maybe we can say small object wise they can touch it very well, leather well, make it maybe not so well. Russian teeth maybe uh, decent. Writing pendulous maybe poor. Utensil maybe very poor. Holding cloth very also poor. Mystery and driving is like no use, which mean they cannot even like craft themselves lah. So here we have like a real time computer average for the ML. And we can do the next step. So using this score here and data we gained before, so what we can do is here also we can leave any notes about what happened in the first therapy or maybe on the therapy session itself. Then we can do for the encounter, and this will send to the backend. And using the data that we have, it will predict everything that I needed in the dashboard. First is it will show you what the baseline, which is the what's the first condition of the patient itself. And the actual outcome is basically what's the highest predicted potential recovery that the patient will have. You see, Abu here has the possibility to gain 2.84 out of 5 recovery out of 2.84 out of 5 for recovery. You see, he will not have fully recovered from the stroke. So here also we have the progress summary auto summarization. Here we will say like here is basically can an AI course for disease. For while target high sensitivity to stroke type safety status high risk. It's basically the quick summary of the detail of the condition itself. Here we have the predictive test ROI, which means they are predicting which is the which of the activity that we used before will give the highest impact on the mal recovery itself. Right now, say the driving is the huge factor in recovery of the motor activity, the motor action. Here we have the adaptive task sequencing is basically here now they show all the that we see before, and they show how many load that are needed for each uh, activities and how the sequencing will be so that we can reach the most optimized recovery roadmap. For example, right now from the AI say that we need to uh, use this particular order of action using this particular offload to gain the maximum or the optimized recovery action. Now here you can see uh, that mentioned that by following these particular orders, it will give 9 additional minutes of active therapy before hitting the fatigue ceiling, which is which can affect the effectiveness of the therapy itself. Let's say we change the combing hair to here instead of the fork spoon first, and it also affect here. So it say that you can see instead of 9 additional minutes, they will hit the active therapy fatigue ceiling faster compared to the original order. And we can go to here, the analytics tabs, which contain all this SAI implementation. Here you can see we have like, this is the factor that we take to account for the model. So they will show you how much each factor affected the prediction model. So here that one of the biggest one is the pathology classification for the model lah. And here you can see why it's like explanation of why the factor are affecting the particular uh, model. Right now, we can see the positive factor that may increase the chances of recovery is the initial stroke severity. Then you can see also here the factor that don't really like give chances or like may reduce the effectiveness of the therapy is the pathological classification. And on the right side, I know this is all the medical term. So we also put a guideline here to see what actually each term are supposed to be. And here we have the prescriptive intervention roadmap, basically saying uh, what need to be done to achieve uh, to make sure the recovery is on track here. Also have cohort benchmarking, which use the global database, which is the clinical, clinical database, clinical global database to see how well the patient is recovery compared to others. Then under here, we also have the recovery trajectory, which is here. We can see the first session is right here. And right now, this is the end. We see the targeted trajectory, how much the patient will recover by the end of the session. Okay, so here you can also see the intensity for each session. So down here, we have the log of the Mars score that was inserted for every session. And we also have the therapy logs that record the data for every session also. Then, let's say the patient come again for another session. So we can go to the form here. Here you can book a session. Maybe you can book it for tomorrow. Okay, and it will come out. So it will come out on the yeah, it will come up here. The upcoming schedule on the calendar itself. So we come back to Abu here. Then we go to the form. And now you see the graph is not like anything, doesn't show anything like particular important, right? So when in the next session they just need to come with the progress. Maybe we do it on the fifth, and the session will estimated intensity will be 3, and the pen level is 2. This is the form. You must the doctor or the clinician must fill it up after the session. So we put the fun motor skill here. Then we can see maybe he improved a bit all of fair, right? So this is where the LSTM come in. So they got all of the data and compute the new possibility. So continue step. Yeah. Then we finalize a counter. Here it show that after this session, it show there's a possibility. As you can see here, this is the next pages. It's not much different compared to the page. Basically, there's no add new session here. It's mostly just read from the data. And you can show here the Abu one. Uh, most of it are similar to the dashboard. The only difference is here in the form where instead of they can add new data, only the doctor can add new data, and uh, the nurse only can book an appointment for the next session and check with the doctor if they need extra in during the therapy session. Now we are in the admin panel of the PAPSOTO25. Right now you can see there's total activity, which is how many patients we have, the 3 hours, and also hospital success rate. Then here we have the system audit log, basically what happened in the system, so that we can observe what happened in the system itself lah. Then here all the patient history, which is all the list name of the patient. Then we should go to here. There's account management. You can delete or edit the account, existing account of the Passport 25. Also, you can add a new one. So let's say my name is Firdaus here. Wait, okay. Let's say my name is Firdaus. So we have created new account here. Autofill the dr.firdaus@passport25.com. Minimum character maybe we use password. Create the account. Now we created the account here, and it can be used. Can still be used
by the website lah basically. Because this one are registered in the database. Now you can see this the account created. Sign into the dashboard. Now you can see new created account dashboard. You can see all blank because no one was assigned to this particular doctor.